This is a video lesson on distance, how to find it, and how to use the distance formula and what it means. So in this first example, if I asked you to find the distance between these 2 points, well, it turns out that because these are in a horizontal line, I can just count out the distance. If you look at the scale of this graph, it says that this is 2, which means that that's 1. The scale goes by 0.5. So I could count them out to be 1, 2, 3, 4, 5 units. And another way to look at that is if I had labeled these points x1, y1, and x2, y2, so that's because the first coordinate is always x, the second one is y, and the subscript 1 just means that that's my first point, and this 2 means that that's my second point. And it wouldn't matter if I had called this point x1, y1, and this point x2, y2, as long as the first coordinate is x, and the 2 coordinates of the same point have the same subscript. So mathematically, what I could have done was I could have just taken this 6 and this 1 and said, well, I went from an x coordinate of 1 all the way to 6. 6 minus 1, that's 5 units. I could have done x2 minus x1. It would have been a quick way to do that. And in the second example, where my 2 points are in the same vertical line, again, what I could do is I can just sort of count out the units. I know that this is 2 units below the axis, and this is 4 units above the x-axis. So in total, that's going to be 6 units. And if I tried to use that same trick, the y2 minus y1, negative 2 minus 4 is negative 6. So actually, I would have to take the absolute value. I just want the positive. My distance should always be positive. And we'll talk about that in about a minute. But it's the difference that I'm looking at between those y coordinates. And most generally, if I had 2 points and I wanted to find the distance between them, and they're not in a horizontal line with each other, and they're not in a vertical line with each other, this is really the distance that I'm looking for. Between any 2 points, x1, y1, and x2, y2, it's this. It's the direct line between them. So how do I find that distance? Well, it turns out that on a Cartesian plane, what I can do is look at this, the horizontal distance from one point to the other, and also this, the vertical distance from one point to each other. And on the Cartesian plane, those two have to be 90 degrees to each other. That's going to be really important for being able to find the distance. Because horizontally, I've gone from a value of x equals 1 until a value of x equals 4. That's 3 units. And vertically, I've gone from the axis to a value of 4, or from a value of 4 down to the axis. That's 4 units. And because this is a right angle, my distance I can find by using Pythagorean theorem. I can say that d squared is equal to 3 squared plus 4 squared. And when I solve for d, I end up taking the square root of both sides, so it means that d is equal to the square root of 3 squared plus 4 squared. And 3 squared is 9, plus 4 squared is 16. 9 plus 16 is 25, and the square root of that is 5. It means my distance is 5. And most generally, if you look at how I came up with that 3, what I did was I took x2 and I subtracted x1. And most generally, to get this over here, I would have done y2 minus y1, or y1 minus y2. But that thing that I was talking about with the absolute value, how do we make sure that it's positive? Well, it turns out that because we are squaring those numbers, it wouldn't have mattered what order I subtracted them in. So if instead of doing 4 minus 1, so 4 was my 4 was my x2, and 1 was my x1, if instead of doing 4 minus 1 to get 3 and squared, if I had done 1 minus 4, I would have gotten negative 3. But because it's in brackets and because I'm squaring it, I would still end up with 9 anyways. I'd end up with the same answer. So this formula is most generally for any 2 points, x1, y1, and x2, y2, how to calculate the distance between those points.